Hi viewers, this is Dr. Gunamani Jana, and in this video lecture we will be covering the k nearest neighbor algorithm. So in our supervised learning we covered a number of algorithms, and here we will be mainly focusing how this k nearest neighbor or the KNN algorithm works. Fine. So for this let me introduce this KNN and yeah. This, as you understand, k nearest neighbor, it is one of the machine learning algorithm. It is based on the supervised learning techniques, right? So what is the principle here? It works based on the similarity between the new data and available data, and put the new data into one of the categories, right? So all the data we divide into number of categories. So the new data based on the distance, the Euclidean distance between them, so it can be put to one of the categories. So based on the similarity only, that is the principle. And the second point, KNN algorithm, it stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well suited category by using the k nearest neighbor KNN algorithm, right? So this KNN algorithm, it can be used for regression as well as the classification, but mostly it is used for the classification problems, right? So it can be used for both regression as well as the classification. So it is a non-parametric algorithm, which means that it does not make any assumptions or any underlying data, right? So this is the thing. So it is purely based on the geometrical distance, right, or the Euclidean distance, whatever. So that's why it is also sometimes called the lazy learner's algorithm, because it does not learn from the training set immediately. Instead, it stores the data set, and at the time of classification it performs action on the data set, right? So it try to make some cluster or make some k number of points. So based on that it checks whether all the points are nearer to that one, right? So based on some similarity. Now KNN algorithm at the training phase just stores the data set, and when it goes new data, then it classifies that data into a category that is much similar to the new data. That is the thing. Here let us take, suppose there are two categories, category A and category B. Two category of data are there, and we have a new data point that is x1. So this data point will lie in which of these categories, whether A and B, that we are going to do it here now. To solve this type of problem, we need KNN algorithm. With the help of KNN, we can easily identify the category or class of the particular data set. Now how it works, now see, this is the methodology of this algorithm. Step 1, select the number of k's. Okay, how many number of points we want it there, to how many clusters you want to put it there, you put it there. Then calculate the Euclidean distance of k number of the neighbors. So from this k, all the surrounding neighbors were there, you calculate that distance, right? Euclidean distance, you know, x2 minus x1 square plus y2 minus y1 square, there square root all the things, you can calculate the distance like this. Then take the k nearest neighbors as per the calculated Euclidean distance. So this is the step 3, it is 4. Then step number 4, among these k neighbors, count the number of data points in each category. How many are there in each category? So suppose 5 categories, A, B, C, D, E. In A category how many there, B category how that, count it, right? And assign the new data point to that category for which the number of the neighbors is a maximum. Okay, this is the, and now step number 6, our model is ready. So now then what we do, first we choose the number of neighbors. Here we have we can select k is equal to 5, right? Now next we will calculate the Euclidean distance between the data points, and the Euclidean distance is the distance between 2 points which we have already studied in geometry. It is just like you can see here. Suppose this point is x1 y1, this point is x2 y2. So this distance how to calculate? Up to this it is x1 and up to this is x2. So x2 minus x1 is this distance. Similarly, this is y2 minus y1. So this is this distance. Okay. So this square plus this square, which is equal to, so this is b and this is p, their square is equal to h square, the hypotenuse here, and the square root is the distance. Get it now? So similar way we got it there now. Now suppose now I want to add a point. So it is a new point. So you see two category I made it. One category it is just like some coming some greenish color, and one is coming blue color. It is not exactly you can say it is the some color is like that turquoise blue, right? So this is the navy blue, like that. So these are two different category. Now a new data point is there. So new data point, if you see here this is close to 3 in this category, and it is close to only 2 in this category. So in that case it will be assigned to A. That is the same principle it works. Say what are the advantages? It is simply to implement. It is also robust to the noisy training data, and it can be more effective if the training data is large. So that is the thing you do it here in these things. Now let us come for the implementation. Suppose we go for a car manufacturing company that has manufactured a new SUV car, and the company wants to give the advertisement to the users who are interested in buying that SUV car. So for this problem, we have a data set that contains multiple users information through the social network, and the data set contains lots of information but the estimated salary and age. Based on this, we are going to consider these are the independent variables, and the purchased variable is the dependent variable. Okay, what is the salary and the age? So this will be the independent variable, and what we are going to predict, that is the purchased the variable purchased, this will be the dependent variable. Okay, now we got the some of the theories. Now let us go to our implementation part. In the implementation part, we can go for we are implementing in the Jupyter notebook. Here first of all, we go for importing some of the libraries like the pandas and numpy. So import pandas as pd, import numpy as np, then import matplotlib dot pyplot as plt, and import seaborn as sns. All the things you do it here. Then I am using the social network underscore add csv file, that is the data set. It is there already there. I will show you, it is already I uploaded here. Then for reading that one, pd dot read underscore csv, that is saved as train. Now train dot head, first 5 rows of data you can see it here, and is there any null value or blank data? Then how to calculate that one? Train dot is null dot sum. So for age there is no null value, and for estimate salary there is no null value, and for purchase also there is no null value, right? So then it is fine. Then while you run this sns dot heat map for train is null ethic. So like that you do it here. So the heat map also it will show you, because I am not running this one. You run it, some it will appear, not necessary. But if you want to run, just remove this hash and run it. It is coming. Then this sns dot set style dark grid. Then I want to plot this one. For this, what I do, plt, because I already to matplotlib, it is already saved as plt. So plt dot figure size is equal to 10 by 7. You see the size length and width. Then sns count plot. Here x is equal to age, and data is equal to the train, right? So based on this, we have plotted this one. So this is the age and this is the count. You can see the age group 18, what is their purchasing count, how many people are there, and age group of so if you see this age group of around 35, 37 or like that. So this group, see 23 to this one, this group 42. So maximum people, their purchasing capacity, number of people are more, right? Then again I want to plot it. Plot figure size 1510, sns count on x is equal to age, and here it is gender, and that all the things in red blue. So now you can see how many, because I want to here how many people are there, male and female in this category, they are interested for these things. So in this age group 18, blue color is representing the male, and I think the the orange color is representing female. So 18 age group, this much of male and this much of female, everything you can check it, especially for the age group of say 35, number of males are more than this one, and the female. So all the things we can count, right? Then what you do, plot figure size, this one sns, you go for the joint plot where x is equal to age and y the estimated salary. That means it will be plotting the age in the x-axis and the estimated salary in the y-axis. You can do it here, and it is a scatter plot also, you can understand. So by plotting all the things, so here age and here the estimated salary, but in addition to that also the data is also plotted here. It is related to the age, so you can see the age group of this is maximum here, and there also estimated salary also you can see for you can clearly see it here, right? So then we want to find something like that, some so suppose some dummies like gender is not required for me, because while somebody is purchasing a car, why do I need a gender? So train gender drop first is equal to true, then train dot pd dot concat train sex axis is equal to 1. So with this, so what I added, we added that first we yeah. So this gender we added here, okay. So then here these are the user ID, this is the age and estimated salary, previously it was there. So actually male and female it was there, then we already put it the gender is equal to male or female, so we put male is equal to 1 and female is equal to 0, like that we can put it there. Then trend dot gender axis is equal to 1 in place of true. So if you go for that one, now this is already removed. Which one? Gender is gone, okay. So only user ID, age, estimated salary, purchased, so there it is coming, right? So then from sklearn.model select import train test split date. So because now I want to split some data, so x is equal to train dot dot purchase. So because I am going to predict the purchase, so I drop it from this data set. So train dot drop, which one? Now purchase and axis is equal to 1, that you save it as x. That means except purchase remaining are there saved in the x axis, x and y are train purchased, right? So if you calculate y, you can see only who the purchase capacity it will be showing. So similarly if you purchase that x also, the remaining it will be showing. So except it is 400, because there are 400 rows of data and here only 4 columns I am telling, right? Then x train comma x test, y train and y test, which is equal to train test split, this is the method, and you are using x, y, test size is equal to 0.25, okay, because training is 75%, test is 20% we are taking, and a random state is equal to 101. And from sklearn neighbor import k, because KNN, so I am using the k neighbors classification, and KNN is equal to KNN k neighbors classification, that n underscore neighbor is equal to 5. I am taking only 5 here, k value is I am taking 5. So then KNN dot fit x train and y train. So what is our data? We decided only 75% we are going for training, that is stored as x train and y train, that I am fit to the KNN. Then it has run successfully, there is no issue. Then for the prediction is equal to KNN dot predict, when I am giving this x underscore test that I am giving, then it has to predict. So it has predicted also, it is fine, it has come, all this prediction it has come, alright. Then y test also you can do it here, this is also coming here, we don't have any problem on that one. And then we can go for this, some confusion matrix, we can go for that one. So then from sklearn.matrix import classification underscore report, the confusion matrix, and print classifications report, y test and predict. So all the precision it is showing, the recall and F1 score support, everything, all the details it is showing. Then how to find the k value? We have first of all find the error rate. For calculating the error rate, you are using for I in range 1 to 20, KNN neighbor classification n neighbors, which is equal to I, KNN dot fit x train y train, predict underscore y is equal to KNN dot predict x test. So error rate, how do you get it? So prediction of y minus y test, okay. So predicted and the actual value, the difference we find it there, so that is the error, okay. This is the way we find the error rate, right? So that's why error rate dot append np dot mean, what is the mean value also, we get it there. Now we are going to plot, so plt dot figure size 10 by 5, so plt dot plot range 1 to 20, error rate and color I am putting it green, so line style is equal to dashed, and marker is equal to 0, so marker face color is equal to red, marker size is equal to 10, like that you put it here. Then what is the plot title? Error rate versus k value. Then x label we are putting k value, and y. So if you run this one also, it is coming like this, you can clearly see, okay, the k value and the error rate it is coming here. the error is minimum here, you can see it here, right? So from sklearn import, so this is up to this we have successfully completed our k nearest neighbor. I hope it is very useful for all the researchers who are going to do their btech project or mtech project using this type of algorithm. So if you like this video, please do share, and also if you want this coding also, please do write some comments or sms, and subscribe. I'll be able to send all this code to you directly. Thank you for watching this video. Take care of your health. Goodbye.